Hello dear students. Next we are going to an important topic in module 5, which is interconnection of two-port networks. I am telling that this topic is important because this topic is giving us a shortcut to solve problems. You might have seen that certain problems of two-port networks become really long or become complex, because the equations keep on going big and big if we have the number of capacitor and inductance increasing with the length of the circuit. To avoid doing lengthy calculations, we can use the concepts that we are going to study in interconnection of two-port networks to help us solve it much more easily. Now, if you look into your syllabus, interconnection of two-port networks has basically two topics. One is series connection and another one is parallel connection. But we will take three topics here because, as I told you, this does not come as a separate question, but it helps you to get a shortcut for solving the problems. And you can use this concept for solving the problems and getting the answers. So what is basically interconnection of two-port networks? Suppose we are having two networks whose parameters are known. Now we know that any two-port network will have Z parameter, Y parameter, H parameter, and transmission parameter or ABCD parameter, also called as T parameter. Out of these four, we can calculate Z and substitute in equations that relate in interconnection, which we have actually seen in previous section. Let me take that. If you remember, we have seen interconnections, and in interconnections we can use those formulas, the interconnection formulas, and find out between one and the other between one and the other parameter, what is the relation, and using those relation, for example here. So if you know Z, you can find out the same Y parameter, H parameter, and T parameter using the Z parameters. And this is one of the important shortcuts. The other shortcut that we are going to study here is interconnection of two-port networks. Now, in two-port networks, suppose we are having two networks which need to be interconnected. Now, there are three ways in which it could be interconnected. One of the ways is what is called as the cascade. What is called as the cascade connection. So, if you would see, cascade connection is not there in your syllabus, but still I will teach you because this is a very important shortcut, and you will find it helpful. So what is cascade connection? So this is the first one, cascade connection. See, in cascade connection we are having two-port networks which can be connected in this way as if they are one after the other. That means we are connecting them in cascade. Okay, so what we have done, we have connected the output of the first network with the output of the second network. Now suppose if I am having the T parameter of the first one as A1, B1, C1, D1. Suppose this is the T parameter of the first network, and let the T parameter of the second network be A2, B2, C2 and D2. So I have got two networks whose T parameter is as I have written here, and I have connected them in cascade. Now why I am saying cascade? Because I am connecting one after the other by connecting the output of the first one with the input of the second one. Okay, this is the cascade connection. So if I am having cascade connection, then I can find out, or I can replace this with a single uh, two port network whose two port network parameter, let me write it as A, B, C, D. I can find out this A, B, C, D by simply multiplying the first matrix, which is A1, B1, C1, D1, multiply it with matrix multiplication, multiply it with A2, B2, C2 and D2. So if you are able to find out, the matrix by multiplying this first two port network transmission parameter and the second network two port network transmission parameter, you multiply both of them, you will get what is the A, B, C, D parameter of this network. That means you can connect two networks and make it into a single network whose two port transmission parameter you can find out. Now don't think that this can be done with the Z parameter also, or with Y parameter also, or with H parameter. Only T parameter. Only for the case of T parameter. So I will write here because I don't want you to make a mistake. This is only for T parameter. T parameter, you all know, T has to be capital T. So T parameter. So only with the case of T parameter I can do it. I cannot do it with the Z parameter or H parameter or Y parameter. Only with T parameter. Okay. So this is a shortcut. So if you are having, a network, suppose a single network, let us take any of the previous problems we have done, and I will be able to explain you there. Let me take any of the previous problems. Suppose I am taking this parameter, this particular network, then instead of doing the whole problem, I can take this part of the network to be separate, and connected to the first. That means I can imagine this as two networks, one which is basically like this, the second network which is having this pie shape, and find out what is the T parameter of this network, the first network, and find out the T parameter of the second network, multiply both of them, and you will get what is the transmission parameter of this one. And you might be thinking, how to find out. See, we have already seen how to get directly the Y parameter of a pi network. From that we can get the T parameter using interrelation, and from that we can find out. I will do it with the help of a problem later. So let us go back. So this is the cascade connection. So what you do, you multiply the transmission of the transmission parameter, which I will name it as matrix T1, and matrix, the second parameter, suppose it is T2, then the transmission parameter will be the new transmission parameter, or the transmission parameter of the combined block will be T is equal to transmission T1 multiplied with transmission T2. Okay. So this is for the case of cascade network, cascade connection. That is one of. Now remember, we have to prove it, and I will prove it. Okay. The proof I will take it separately. Let us go to the second one. The second is basically called as a series connection. Okay. Or even I can take parallel connection, but first I will take series connection. So the second one is series connection. Now what is the meaning of series connection? Now many people make the, or think that this one is basically your series connection. No, this is cascade connection. What happens in series connection is, see, why do we call it as series connection, that you have to understand. Suppose I am going to connect the first this one with this second one, and the bottom part I am going to connect with this bottom part, and similarly this one I am going to connect with this, and here I am going to connect between these two. Okay, so this is how I am connecting two ports. I call this as this is called as parallel. Let me call this as parallel. Okay, series I will draw after this. So this is parallel connection. See, what happens in a parallel connection is you are connecting two blocks in parallel like this. You are connecting two blocks in parallel like this. See, generally, why do we call it as parallel? You may feel that, okay, see, one block is parallel to the other. The main reason is because the current is dividing, total current is dividing between these two branches. And here the output current is coming out of these two branches. Or, we can draw it in the opposite direction also, no problem. But this is the reason why we call it parallel, or you can even see that two blocks are parallel to each other. But in series connection you will find out that this almost similar structure comes. But anyway, what you should remember, why is it called parallel, is because the current is getting split between two. See, this is the current, this is the current, incoming current. That incoming current is getting split between two branches, and we know that only in case of parallel circuit, we will have the current that is coming getting split up into two branches. That's why it is basically called as a parallel connection. So in case of parallel connection, the term that we use is basically Y, the Y parameter. So suppose this one is having a Y parameter of Y11, let me call it as Y dash. So Y11 dash, Y12 dash, Y21 dash, and Y22 dash. Suppose that is the Y parameter. And for the second case, I am going to have again Y parameter, which is now going to be represented as Y11 double dash, Y12 double dash, Y21 double dash, and Y22 double dash. And suppose I am going to connect them like this, that is in parallel connection. What is going to happen is, suppose if this is Y dash and this is Y double dash, then the total Y will be Y dash plus Y double dash. That means the value here, which I am writing it as Y, it is Y11, Y12, Y13, and Y21 and Y22. Then I can get Y11, Y12, Y21 and Y22 as the addition of both the Y's, which can be written simply as Y11 dash plus Y11 double dash, Y12 dash plus Y12 double dash, Y21 dash plus Y21 double dash, and Y22 dash plus Y22 double dash. Of course, I have to prove it, that I will do it in the next section. So this is the case of parallel connection. And why do we call it as parallel connection? Because I told you the current is getting split between two branches. Now the last is basically the series connection. series connection. So the third is series connection. And in case of series connection, what we are having is we are having two networks which are, you know, in connected in such a way that we are having a series flow of current, or the voltage is basically in series. Okay, how do we say that the voltage is basically in series? See, if I am suppose going to connect the connection between these two, suppose if I am going to connect it by connecting it here and connecting it here. Now people may confuse it that, you know, this is parallel. No, this is not parallel, this is series, because see, have a look here. Whatever is the V1 voltage, V1 dash voltage, and suppose this side, the second one, it is V, not V2, it is again first port. So this one is also V1 only, but because it belongs to the second one, we will call it as V double dash. Similarly, the output voltage, which should have been V2 dash and V2 double dash. See, the total voltage that we will look into this particular connection is this voltage, which is actually what? It is the series connection of two voltages, which I will call it as V1 dash plus V1 double dash, correct? Similarly, here also I can write the total net series voltage as V2 dash plus V2 double dash. Okay, and so based on this I can find out, you know, what is the total uh, net value, or what is the total parameter, z parameter. For example, suppose the first one is having z11 dash, z12 dash, z1 sorry 21 dash, and z22 dash. Similarly, the second one is having a z parameter which is given by z11 double dash, z12 double dash, z21 double dash, and finally z22 double dash. Then I can find out the z parameter. I can find out the z parameter by, I can find out the z parameter. Let me write the z parameter. The z parameter here, suppose if it is z11, z12, z21 and z22, that is the net z parameter, which I will call it as just z. And the first, let me call this as z dash, and this is z double dash. The parameter z dash belongs to the first one, the z double dash is the z parameter of the second network. Then I will get z to be equal to simply the addition of z dash plus z double dash. It is quite simply this, z dash plus z double dash. So it means that our z will be simply z11 dash plus z11 double dash, z12 dash plus z12 double dash, similarly z21 dash plus z21 double dash, and finally z22 dash plus z22 double dash. And that is what is going to be our total z parameter of the two port network which are connected in series, So these are the three connections. Remember, this one is not there in your syllabus. I taught you this one because again, for solving problems, cascade connection is really useful, and even parallel connection and series connection is also very, very useful. Okay, so next I will do the proof of this one later. First, let us do some problems based on this. Look at this particular problem. Find the y parameter of the network shown below. So this looks like a complicated network. Now here you can see that, let me take different color. You can see that there are two networks. One is this network. Okay, one is this network, which is a T network, and the second network is, let me use a different color. The second network is this network. Okay, and both these are T networks, and both these T networks, if you would see, are connected in parallel because their connection point is shown here, 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 correct? It is not shown in here. Here there is no connection between any of the networks. It's very clearly shown, so no need for us to consider that there is a connection between. In certain cases, certain textbooks, here you might be finding a jumper, but here they have not drawn, but here they have clearly shown where the connection is, and that point is shown here. So you can see that there are two T networks, and these two T networks are, let me draw it separately, and I will directly draw it, and I will do another thing, and that is that I will draw it in such a way that I will do the transformation also and draw it. For the first one, this is a capacitor, the second is also a capacitor, and the branch coming down is a resistor. Okay, so this is the first network, and the second network is a 2 ohm resistor with another 2 ohm resistor, and coming down you are having a capacitor. You should be able to see this, otherwise there is no point in solving because you will not understand what is going on. Okay, so now based on this transformation, it will be 1 by S ohms. This will be 1 by S because it is 1 farad, and we know the equation is 1 by Cs, so C is 1, so 1 by S. And this is again 1 ohms. This one is 2 ohms, 2 ohms, and this is going to be 1 by 2S. Okay. Now see, both of these are T networks, and we know that for the case of T networks, so let me write down, I have started with the solution. So we know that for the case of T networks, if I am going to take a T network, and we have all studied this, that if you are having a T network, then suppose if the T network is having impedance value in the branches like Z1, this is suppose Z2, and this is Z3, then I can directly write the Z parameter as Z1 plus Z2, and this one is going to be Z2, this is going to be Z2, and this one is going to be Z2 plus Z3. That means this will be a combination of these two, and this corner will be a combination of these two, and the two corners here and here we will be having what is the middle branch. And this is basically called as a T network. Don't confuse it with T parameter. Many of you have confused this with T parameter in your examination paper, your series test. Please don't make that mistake. T network is different, T parameter is different. Here this is called as T network because it is having the shape of T. You can see that it is having a shape of letter T. Okay. Whereas T parameter is ABCD parameter. Anyway, so if that is the case, and if I consider this as a T parameter network, then I can directly write the Z parameter of this one as so it is 1 by S plus 1. This one is going to be again 1 plus 1 by S, and the corners are going to be 1 and 1, which I can actually write it as, I can write it in a simplified format as S plus 1 by S. This is 1, this is 1, this is S plus 1 by S. Okay. And we know that for the case of for the case of parallel, so this is parallel. Okay, this is parallel interconnection. This is going to be a parallel interconnection. So you have to write this, that these two networks are connected in parallel. So in case of parallel interconnection, we have seen that if you know what is the y parameter of the first one and the y parameter of the second one, the total y parameter will be the simple addition. So now I have to find the y parameter of this one, and we know that the y parameter is basically given by z inverse, and you all know for z inverse I have to find what is delta z, and delta z will be s plus 1 square into divided by s square minus 1, which comes out to be s square plus 2s plus 1 minus s square divided by s square, where these two will cancel off, and I will have, let me write it down. So I will have the delta z as 2s plus 1 by s square. So I will have the delta delta z as 2s plus 1 by s square, or I can write 1 by delta z as s square by 2s plus 1. Correct? I can write this. From where now y is z inverse, therefore I can write the y for this one as, you all know the equation, 1 by delta z, and interchanging it is z2 2 and z11, and this is going to be minus z12 and this is going to be minus z21. And where did I get this? I got this from the interconnection. Okay, the interconnection, we have all seen what is the interconnection. Let me take that. I think it is this one. Yeah. So this is the interconnection. So I am talking about this formula. Okay. So if I know the z parameter, I can find out what is the y parameter. Okay. So based on that, I have got this. Now here, if I am going to substitute the value, I will get 1 by delta z is s square divided by 2s plus 1, and so z22 is going to be s plus 1 by s. This is going to be minus 1 minus 1, and this is going to be s plus 1 by s. Correct? So based on that, so this is now y dash because it is belonging to the first network. So I can write directly y dash as, now I will multiply what is outside and I will get s square plus s divided by 2s plus 1. This is going to be minus of s square divided by minus of s square divided by 2s plus 1. This is going to be again minus of s square divided by 2s plus 1, and this is again going to be s square plus s divided by 2s plus 1. So I have got the y parameter of this first network. I have got the y parameter of the first network, okay, which is basically this one. Now I can similarly find out the y parameter of the second network. So let me draw a line. First I will take off this shortcut. Okay, and now I will draw a demarcation line. Okay, because I do not want it to be confused. Okay, so now for the second network, again we can start by writing what is z, because it's a T-shaped network. I can directly write it is going to be 2 plus 1 by 2s. This is going to be 1 by 2s. This is also going to be 1 by 2s. This is again 2 plus 1 by 2s, which I can write it as 4s plus 1 divided by 2s 1 divided by 2s. This is again going to be 1 divided by 2s, and this is 4s plus 1 divided by 2s. And based on that, I can find out y double dash. So suppose this is y z double dash, this was z dash, so it will be the inverse of z double dash, correct? For which I have to first find what is delta z, and delta z is, if you can see, it is 4s plus 1 square divided by 2s square minus 1 divided by 2s square, and there is no need for us to write the cross multiplication is going to be very easy. It is just going to be 4s square, which is 16s square, correct? 16s square plus 8s plus 1 minus 1 divided by 2s square, where delta z will become 2 will get cancelled and one of the s will also get cancelled, so I will get 8s plus 4 divided by s. Okay, why? Because these two will get cancelled off, one of the s will cancel off, and then with 2 I will get 8 and 4. Therefore 1 by delta z will be equal to s divided by 8s plus 4, and this is what I am going to multiply to get my is y double dash. Y double dash is going to be 1 by delta z, again the same equation. It is going to be z22 z11, and this side it is going to be z minus z12 minus z21, correct? And now if I am going to multiply, I will get s divided by 8s plus 4. Now I am going to multiply. So if I am going to multiply with z, so it is going to be here it is going to be 4s plus 1 divided by 2s. This is going to be 1 by 2s. This is also going to be minus 1 by 2s, and this is again 4s plus 1 divided by 2s, correct? Now if I am going to multiply it, I will get y double dash is going to be equal to, so now let me take it inside. So s and s will get cancelled, correct? S and s will get cancelled, and let us have a look if I am missing something here. 2, okay, so here it was 2, sorry, it was 4 here. Here it was 4, not 2 square is going to be 4, so I can get, I can get this as, okay, so this is going to be 4s plus 2, sorry, this is also going to be 4s plus 2. So here I have to also correct that. I'm sorry for the mistake. This is going to be 4s plus 2. This is going to be 4s plus 2. So now s and s will get cancelled, so I will get 4s plus 1 divided by 8s plus 4, and here it is going to be minus of 1 divided by 8s plus 4. Similarly here also minus 1 divided by 8s plus 4, and finally here it is going to be 4s plus 1 divided by 8s plus 4. So now I have got the y parameter of both these individual networks. See, I have used the shortcut here. First shortcut was First shortcut was to split them up as two parallel networks and then take this as one of the T networks, this as the second T network. From T network directly we can find out what is the Z parameter, and then using the second shortcut. What is the second shortcut? The second shortcut is from Z finding out Y parameter. And by simply using the shortcut I have got the answer simply for the first network as this one. For the second network I have got the answer as this one. And now I am going to directly write what is going to be the answer for the total. So what is the question they have asked? They have asked find the Y parameter of the network. Therefore, let me use a different color. Y parameter of the parallel connection, we all know that the parallel connection will be based on y dash plus y double dash, which I can add both of these. Now we know that we can add up the individual components. We can add up the individual components and we can get the answer. So let me just have a look here. So this is going to be okay. Okay, so I will write this as, the first one is s square plus s divided by 2s plus 1 plus this portion, correct, which I can write it as 4s plus 1 divided by, now have a look here, I can take 4 commonly outside, what I will get is 2s plus 1, correct. What I have done, 8s plus 4, I can write it as 4 multiplied with 2s plus 1. And that is what I have done here. Why I have done like this? Because I see that here and here both of them are going to have a common, denominator. So that is the first case. The second case I am going to have is minus of s square divided by 2s plus 1 minus, the second case also I am going to write 4 times 2s plus 1, and here again it is going to be minus s square divided by 2s plus 1 minus 1 divided by 4 times 2s plus 1, and here it is going to be again s square plus s divided by 2s plus 1 plus 4s plus 1 divided by 4 times 2s plus 1. And now the addition has become very simple. Now if I want to add these two, so you can see that I'll just do one of them, and I will, because two components are going to be same, so I will keep this here. And now I am going to find out. So this is going to be equal to, if I am going to find out, so here if I am going to do, common will be 4 times 2s plus 1, and by doing I will get 4s square plus 4s plus, the second part is 4s plus 1, where this 4s and 4s I can calculate and write it together at 8s. So this one and this one I can write together. So I will write them totally as, you can check it, as 8s plus 1. Correct? The same thing is going to be here also. So here also I will write 4s square plus 8s plus 1 divided by 4 into 2s plus 1. Now I can multiply this one inside and write it as 8s plus 4. If I want to write the denominator like that, I can write it like that. There is no issue. You might be thinking, so where do we stop this, because how do we get the mark? Suppose if we stop it by this one, no, always try to reduce and keep the numerator and denominator as some polynomial. That will be always good. Okay, The second case, it is going to be minus of 4s square minus 1 divided by, again, 4 times 2s plus 1. Similarly here also it is going to be minus of 4s square minus 1. So minus of, sorry, so this is going to be minus of 1 divided by 4 times 2s plus 1. And I can take this minus commonly outside. Similarly here also I can take minus commonly outside, and this is what is the answer. See, you can now understand what is the shortcut, because see, if I have wanted to find out with originally using KVL, KCL, how complicated this would have been. It would have been really complicated. And that now we have solved it very simply by doing this one. Okay. So this is basically what we are having for the case of a parallel network. Now I will show you another shortcut also. To get it very simply, you can do another shortcut. Let me just show you. You may do it, you can do it, or you may avoid it. So the circuit was basically this. This was basically the capacitor to capacitor and this. Correct? Now this is basically your capacitor. So what was the circuit looking like? 1 by S, all ones. So this is going to be 1 by S. This is also going to be 1 by S, and this is going to be 1 ohms. Correct? See, this looks like a star network. Okay, how it looks like a star network? So the capacitor, suppose it is like this. The second capacitor is also like this. The third one, which is the resistor part, suppose it is coming like this. Now what you have got is basically a star network. And you all know that the star network can be connected to a delta network. How? We can draw a delta network which basically looks like this. Here you are going to have some value. Similarly, here you are going to have some value. And here you are going to have some value. Correct? And you all must remember the star delta rule, the rule of which says that, suppose if this is 1 by S, this is 1 by S, this is 1. Okay, so here this value, let me take a different color. Yeah, this value will be these two components added up, which is 1 by S plus 1 by S, correct, plus these two multiplied, which is 1 by S into 1 by S, okay, divided by the third branch, which is this one. So if you want to find for this case, you take the two branches which are on the either side, and the third branch is this. So divided by the third branch, which here is 1, which if you would see, this would come out as 2 by S plus 1 by S square, which you can get it as 2S plus 1 by S square. Am I correct? So that is going to be that one. Here, for this case, again the two branches are 1 plus the second one is this one, which is 1 by S, plus the multiplication of both, which is 1 into 1 by S, divided by the third branch, which is this one, which is 1 by S, which comes out to be 1 plus 1 by S plus these two cancel off. So I will get 1 by, sorry, not 1 by, I will get only 1. Correct? So which is 2 plus, which is 2 plus 1 by S, which comes out to be 2S plus 1 by S. So this is going to be that one. Same is the case here. Here also it is going to be 1 for this one plus 1 by S plus 1 by s, which is this one, and the third branch, which is third branch, so I will multiply 1 into 1 by s, that is the first two branch, divided by 1 by s, which again it will give me the same as this one, which is 2s plus 1 by s. So I can now write this star, I can directly write it as a delta, and the delta is going to look something like this. So here is the first, and here is the second one, which is connected, and the third one, which is connected like this, okay, and the bottom one, okay. So this is what is my delta going to look with the value. Now look here very carefully. The value here is going to be, the top one I just now found out is 2s plus 1 by s square ohms. This is in ohms. And this one is going to be 2s plus 1 divided by s ohms. And this is also going to be 2s plus 1 divided by s ohms. Okay. Now this one I can very clearly write as, or I can redraw this one as, see how I am going to redraw. This one I can redraw as, this branch as such it is going to be there, correct? The second branch is, I am opening it up like this, and there is no problem in opening up. Why? Because this connection I can open it up, and that is what I have done. I have opened these two connections, and now I have got something like this with the value here as 2s plus 1 divided by s square ohms. This is going to be 2s plus 1 divided by s ohms. This is also going to be 2s plus 1 divided by s ohms. Correct? So now, based on this, I have done what? I have converted a T network. I have converted a T network. So this was my T network. This was my T network. And this T network I have now converted to a pi network. You can all see the pi network. Why is it called as a pi network? Because this looks like the letter pi. Correct? So I have converted this from T type network to a pi network, and when we connect it like this, when we connect it into it from a T to a pi network, we have always seen that if suppose we are having, so I have done this conversion. Now we all know a shortcut, that if we are having a pi network whose values are given by, now very carefully look, because people make mistakes here sometimes. So suppose the values that are given here are, this is y1, suppose this is y1, this is y2, and this is y3, then the y, so when I am saying y2, this is y2 more, this is also y2 more, this is y1 more. That means y2 more is what? It is whatever is the impedance, the inverse of that. So suppose the impedance was Z2, I take the inverse of that, then it becomes y2. Similarly here, if I am having, so Z2 is in what? Z2 is in ohms, Z2 ohms. If I take the inverse of that, I will get y2 ohms. Correct? If this is the case, what I have studied, or what we have seen in shortcut is that for a pi network, you have seen it in one of the worksheets, that for a pi network, the value of the impedance basically is given by y1 plus y2. That means the addition of these two. Similarly, this corner, it is the addition of these two, which is y2 plus y3. And what is common between them is this y2, which comes out as the corners here. So it is minus y2 here, and similarly minus y2 here. So if I am having this as the case, I can directly write the y parameter of this one, but before that I have to convert it into mho. So for doing that last part of the conversion, I am again going to redraw this one, and I am going to draw it like this. This is going to be the top element, this is going to be the side element, this is also the other side element, and finally I join them together. Now I am going to write the inverse of z, whatever I have got. So this is s square divided by 2s plus 1 mho. This is s divided by 2s plus 1 mho, and this is again s divided by 2s plus 1 mho. Not ohm, sorry, it is mho. And with that, see, I have done this conversion. You might feel that, okay, sir has taken a lot of time to basically go from here all the way and bring it here. No, if you are regularly practicing this will come very easily. This will come very easily. Okay, but you have to practice, obviously. Now, when you practice like this and you get like this, you can directly write the y parameter as, so now let me write the y parameter. So y parameter is the first one in this corner, it will be the addition of these two, which is s divided by 2s plus 1 plus s square divided by 2s plus 1. And this corner, so this is the first corner, and this corner it will be again, if you would see this corner, the second corner, you will find out that this is again going to be the same one, which is these two. So it is going to be s square divided by 2s plus 1 plus s divided by 2s plus 1, and these two corners are going to be minus s square by 2s plus 1, and this is going to be minus s square divided by 2s plus 1. Clear? Where I can write these two, the denominator is common, so there is no trouble. It is going to be not big a trouble for me. Now I can directly write this as s square plus s divided by 2s plus 1. This is going to be minus s square by 2s plus 1. This is going to be minus s square divided by 2s plus 1. And this is again s square plus s divided by 2s plus 1. Simple. Yeah, now have a look at the answer for which we had got previously. That means you can see what is the answer we got here. It is the same answer. It is the same answer that we have got here, this one. Correct? So what does it prove? It proves that, see, you are having lots of shortcut to use. You can either use this shortcut that we have done here, or you can use this shortcut. Now you might feel that, okay, this shortcut is a little bit longer. No, if you practice it, this shortcut is the smallest. This will really help you. And that's why I said that, interconnection, first time when you do a problem, you will feel that it is very lengthy. Even this problem, I took a lot of time to explain. This concept has gone for 53 minutes. But once you will see that, once you see what is happening here, you can very clearly understand that it's a very simple step for doing the problems. So this we had done for a parallel interconnection. For the case of worksheet, I will give a problem on the series interconnection. If you are having a complicated circuit like this, just look at what the parameter they are writing here. This is one of the shortcuts. Another shortcuts. By looking at y parameter, you can say that, for the case of interconnection, for parallel connection it is always y, for series connection it is always z. Correct? So if you are asked if you are given a little bit complicated circuit, you can find out whether it's a parallel connection or a series connection. Okay, or even you can do for the case of cascade connection, but since it's not there in your syllabus, we will not discuss it. We will only do for the case of parallel connection and serial connection. Okay, series connection, sorry. So here we are having the problem solved in this way. The same thing, you can try that star delta here also. You can try that star delta. It's not going to be very complicated. It's, as I said, it's going to be real easy. So just try it and see if you will get the same answer as this one. And then again, for the interconnection, we all know that we have to add them up, which you will get by adding. Thank you.